Hey, welcome back. We're going to take a look at solving some word problems here as we finish up our working unit 2. Content found from section 3.2 in your text. So when you want to go find problems, there's a good place to go. All right, quick run. When we're solving percent problems, there are really three different kinds. You can read the slide. Sometimes you're going to find what percent one number is of another. Sometimes you're going to find out a percentage of a number. And sometimes you'll find a number when a percent of that number happens to be known. And if I do a good job, you'll see examples of all these types and we'll run right through. Now, your author's a big advocate of this portion formula, and here it is. And honestly, it works fine, and I'm not allergic to it. It's a very algebraic feel. We'll go P for portion, B for base, and R for rate. I'm feeling some of you in previous learnings here played around with words like part and whole. And to a certain extent, that's all we're doing here. It's a little bit of a semantic swap out. You're going to use portion with this book where you once upon a time heard the word part. And you're going to use base for this book where you once upon a time heard the word whole or total. So if that has a click to you, that's fine. Your author sometimes says, hey, you know what would be really cool if we could just run away to change and find a different formula that would let us find a different value, like for instance, maybe the rate. Me personally, I don't know that it's worth memorizing that formula on the right-hand side because I kind of think you could just be able to go ahead and solve for R using your algebra sense. So from my perspective, stay with P equals BR. And if you have to find out what base is, just do what you got to do in the midst of the algebra. All right, an example for us. All right, M&M's has done some research. They realize that 80% of their sales coming from sales of peanut M&Ms. And this particular month, their sales amounted to a grand total of $400,000. And the question says, how much of that was peanut? All right, so in this case, you're looking for the portion or the part. So there's your formula run. All right, your unknown is P. So the base is the 400,000 and the rate is 80% as a decimal at 0.80. And it's simply you and your calculator multiplying, and you find out that this month a cool $320,000 of M&M Mars's sales was from the peanut M&Ms. So in that case, we were finding the portion, okay, or the part. Next problem, I'm a big fan of this. Chester County doing some research on Barbie sales. You'd be proud of me, man. I put my image out there for Math Professor Barbie. I didn't make the cut. So what do you got? Well, you got 500 total Barbies sold. 325 of them were the coveted Math Professor Barbie. And this time the question says, what percent is that? So your unknown is the rate. All right, so there we go. There's a formula firing in. And we've got 325 going in for P, and we got 500 going in for B. Clean divide, grab your calculator, 325 divided by 500. All right, 0.65. So 65% of the Barbies sold for that particular set were the coveted Math Professor Barbies. All right, one more. This time 75% of the people that first are taught got an A. The question says, how many did he teach? So in this case, you know the rate and you know the portion. 33 represents the portion. What you don't know is the base number. All right, so there's your formula. There's your plug-in action, 33 going in for P. Again, for those of you who are part whole people, 33 is the part, and you're looking for the whole number of students. And calculator time for 33 divided by 0.75, and you realize that 44 students were taught that semester. All right. Okay. So if you want to see a separate form, and I like it in a sense because it leads us back to proportions, you can run it that way. So I'm going to show it to you. You can grab either method you're comfortable with. You don't need to go back and forth. Find the one that works better for you and stay there. All right. But if you want a second option, here it is. If you're doing proportions, one of your fractions will represent part over whole. And some of you were taught in the past when you read the problem to look for words is and of. And the number that hangs out with the is tends to be the part, and the number that hangs out with the of tends to be the whole or the total. Your other fraction relates to percent, so your denominator on it will be 100, right? Because that's what we've got for percent out of 100. So there's your general form if you want to look at a proportion solution for these problems. And for the next few problems, I intend to show you both methods. You don't need to do the problem both ways. You just have to be skilled at doing it one way or the other. Okay. So again, semantic action, if you're stuck with the formula, what he calls portion, you may have heard as part. What he calls base, you may have heard referred to as whole. All right, here's a problem for us. We know that Sparky's got some friends who are Packers fans. 40% of his friends are Packers fans. And you know that he's got a total of 2,500 friends. And the question says, how many of them happen to be Packers fans? So if you go proportion, the 2,500 is the whole, and the part is what you're looking for. What part of them are Packer fans? Notice the 40% sets in at 40 over 100 because that's what percent looks like. All right, if you want formula, you're asking me to find the portion. The 2,500 is the base and the rate is 40%. So either way is fine. Don't have to do both. But if you do either way successfully, you find out that 1,000 of Sparky's friends are Packers fans. I got Waldo watching some movies. He watched 448. Of them, 112 were comedies. The question says, what percent of the movies that he watched were comedies? So it looks like you're finding the rate. So in this case, your unknown is over the 100. You don't know the percent. But you do know the total number of movies. The whole is 448. The 112 is the part that relates to being comedy. So there's your proportion. You want the formula. The 112 is the portion, and the base is 448. You're solving for R. Either way gets you to 25% of the movies watched being comedies. One more, 40% of the problems that Sally attempts are correct. Sally's struggling. 6 are struggle. All right, Sally's only solved 50 problems correctly this week. The question says, how many did she attempt? So the unknown is the whole. You don't know the total number of problems she tried. You know she got 50 right, so you know the part. 40% sets in as 40 over 100. Formula look, 50 is the portion, trying to find the base, the rate at 40%. All right, either way gets you to Sally having attempted 125 problems on that particular set. Okay. Last one's a little sneaky because the first thing you see jumping out is the 20%. And on a discount set, be careful. If you're not paying 20, the 20% doesn't correlate to the 224.40, right? If you're not paying 20, you're paying 80. So when the thing that makes this problem deceiving for students is the number you need is hidden. All right, it's not hidden hard. If it's 20% off, you're still paying the other 80%. So there's your proportion attack. The 224.40 is the part that represents the 80%. You don't know the whole price if you weren't able to get the 20% off. So I set that one up by proportion. And if you solved it by cross multiplying, you get $280.50 would represent the full cost if you did not get the 20% discount. If you want that one by formula, you could certainly run it. Your rate is 0.80 and the portion is the 224.40, and you'll be solving for the base. Okay. So either way, I don't care which method makes better sense to you, feel more comfortable with, pick one and roll. That takes us to a section that talks about finding percentages increase or decrease. As it turns out, you do the same thing no matter whether the price goes up or down, in that you find out how much it changes and you compare that change with the original number. What was it before the change took place? On the Mustang problem here, price dropped from 58,000 to 49,000. First thing you got to do is find out how much change that was. So it's a quick subtract for 9 grand. All right, by proportion, you compare that 9 grand to the 58 grand because that's what it was before the change. You're solving for X. You're finding the percent change. If you like formulas, there it is by formula. The 9,000 represents the portion. The 58,000 represents the base. You're solving for R. Don't be scared of uglies. To the nearest tenth, 15.5% decrease in price. Whether it goes up or down, we don't care. Celtic rookie card. Oh, baby, you should hold that thing. All right, bought it for $45.50, sold it for $150. So that's a significant increase. And the increase is $104.50. Remember, when you're doing percentage change, it's relative to the number before the change took place. In this case, that was the $45.50. This one went up in price. Okay, so there's your set by formula. There's your set by formula. In either event, oh, check that out, 2.29. Remember, if it's a number like that, it's over 100%. Shoot, this one's over 200%. So moral of the story, probably should have held on to the Tatum rookie card. It increased by 229.7% in its value. Last one, no harder, just got a little table over there. So from 55 to 2022, we see the change going up by a total of 47 miles per hour. Remember, your base number is what was it before the change? That's the 128. So there you see it set up either way by proportion, or if you want to go ahead and use the formula, and you find that the rate of change is about 36.7%. So that's up. That's up or down in terms of percentage increase, decrease. This wraps up the first activity for Unit 2. Second activity for Unit 2 is going to be that selected set of problems from your textbook. You got to solve them, send them back to me, grab some points. Shouldn't find anything too difficult, too frustrating, I hope. If you do, I'm an email away. Thanks for watching. We'll be back soon with Unit 3. Bye.